Hi everyone, have a nice day. And now I will discuss the thyroid gland. First, I have a learning activities, which is describe the location and anatomy of the thyroid gland. Second, discuss the synthesis of triiodothyronine and thyroxine. Explain the role of thyroid hormones in the regulations of basal metabolism. Identify the hormone produced parafollicular cells of the thyroid. So now I will define what is thyroid gland. So, thyroid gland is a butterfly-shaped organ. The thyroid gland is located anterior to the trachea, just inferior to the larynx. The medial region, called the isthmus, is flanked by the wing-shaped left and right lobes. Each of the thyroid lobes are invaded with parathyroid glands, primarily on their posterior surfaces. The tissues of the thyroid gland is composed mostly of thyroid follicles. The follicles are made up of the central cavity filled with a sticky fluid called colloid, surrounded by a wall of epithelial follicle cells. The colloid is the central of thyroid hormone productions, and that production is dependent on the hormones, essential and unique component of iodine. This is the hyoid bone, superior thyroid artery, thyroid cartilage, common carotid arteries. At most of the thyroid, trachea, hyoid bone, thyroid cartilage, coracoid cartilage. Let's proceed to the posterior view. So, this is the hyoid bone, thyroid cartilage, coracoid cartilage, right parathyroid glands, right inferior thyroid artery, from right subclavian artery, left parathyroid glands, left inferior thyroid artery, left subclavian artery. So this is the last part of thyroid gland. Is parafollicular cell and colloid containing follicle, and then follicle cells, which is covalveolar epithelium, part of thyroid gland. So let's proceed to the next. As you can see in the picture that I showed a while ago. So, Figure 1, thyroid gland. The thyroid gland is located in the neck where it wraps around the trachea. A. Anterior view of the thyroid gland. B. Posterior view of the thyroid gland. C. The glandular tissue is composed primarily of the thyroid follicles. The larger parafollicular cells often appear within the matrix of follicle cells. And now let's proceed to the synthesis and release of thyroid hormones. Hormones are produced colloid when atoms of the mineral iodine attach to glycoprotein called triglobulin that is secreted into the colloid by the follicle cells. The following steps outline the hormones assembly. First, binding of TSH to its receptors in the follicle cells of the thyroid gland cause the cells actively transport I or symbol of I across their cell's membrane from the bloodstreams into the cytosol. As a result, the concentrations of iodide ions trapped in the follicular cells is many times higher than the concentration in the bloodstream. Then move to the lumen of the follicle cells that border the colloid. There are the ions undergo oxidations. Their negatively charged electrons and remove. The oxidations of the two iodide ions result in iodine which passes through the follicle cell's membrane into the colloid. Peroxide. These enzymes link the iodine to tyrosine amino acids in the triglobulin to produce two intermediaries, a tyrosine attached to one iodine and tyrosine attached to two iodines, with one of each of these intermediaries is linked by covalent bonds. The resulting compound in triiodothyronine that is called T3, a thyroid hormone with 3 iodines, much more commonly 2 copies of the second intermediary band, forming tetraiodothyronine, also known as thyroxine. So Unicode thyroiodothyronine, it is T3, or then what we call the known as tetraiodothyronine, also known as thyroxine or T4, a thyroid hormone with 4 iodines. If the thyroid hormones with 4 iodines that we call thyroxine, and then triiodothyronine, what we called it, if T3, it's called triiodothyronine. So these hormones remain in the colloid center of the thyroid follicles until TSH stimulates endocytosis of colloid back into the cells. Their lysosomal enzymes break apart the triglobulin colloid, releasing free T3 and T4, which diffuse across the follicle cell's membrane and enter the bloodstream. So, in the bloodstream, less 1% of the circulating T3 and T4. Remaining 99% of circulating T3 and T4 is bound to specialized transport proteins. It's called thyroxine binding globulins or TBGS to albumin or to the other plasma proteins. This packaging prevents their prediffusions into body cells. When blood levels of T3 and T4 began to decline, bound T3 and T4 are released from these plasma proteins and virtually cross the membranes of target cells. What we call T3 is more potent than T4, and many cells can convert T4 to T3 through the removal of the iodine atom. Regulation of the synthesis. The release of T3 and T4 from the thyroid gland is regulated by thyroid stimulating hormone, or what we call TSH, as shown in figure 2. Low blood levels of the T3 and T4 stimulate and the release of thyroprotein releasing hormone THRH from the hypothalamus, which triggers secretion of THR from the hypothalamus, which is triggers secretion of TSH from the anterior pituitary in turn. The TSH stimulates the thyroid gland to secrete T3 and T4. The levels of the system in which increasing levels of the T3 and T4 decrease the production and secretion of THS. Decrease the production and secretion of TSH. This is the metabolic rate and or T3 and T4 concentration in blood. So, low and high. Low. Hypothalamus release TRH. This triggers THH released by the pituitary. High. Hypothalamus stops TRH release. Anterior pituitary stops TSH release. Negative. So, negative feedback. Elevated T3 and after that, we need to proceed to TSH release. This is the THS release. And then thyroid follicle cells. T3 release and T4 release. Effects of TSH release. Triggers release or T3 and T4 by thyroid follicle cells. Number 3. Effects of T3 and T4 release increase basal metabolic rate of the body cells, raise rate of the body cells, raise in the body temperature, caloric effect. And then the negative feedback. Elevated T3 and T4 levels inhibit release of TRH and TSH.